Hey, we're live. Welcome to another day in technical writing. Someone asked in chat if we're still working on resume review. Yes, we are. There are 15 of you, and I spend somewhere around 10 to 15 minutes with each of you, so it's at least 2 class sessions, but it's turned into about 2.5. And you can expect that for the other couple of writing assignments where I'll have one-on-ones with all of you. So, be ready, especially after we have one of those assignments, to spend class working on your writing while you wait for me to meet with you. I'll try to have more group-oriented assignments where you actually have something to do, someone to talk to. But you should really be taking advantage of your class time to talk to each other as you're writing whatever you're writing, even if they're individual assignments. Speak to one another, flesh out your ideas. For that plain English one that you just did, I think some of you could have definitely benefited from having another eye on some of those complex, old, formal pieces of terminology. So speaking of that one, hard assignment, right? Because reading old 1770s English is not easy by any stretch of the imagination, is it? So a lot of people struggled with the different turns of phrase, different expressions, idioms, all that stuff. Try to think about how much idiom and meme and expression you use today and how difficult it will be to understand you in the future. Not to say that being understood 200 years from now should be one of your priorities in life. It definitely should not. But other cultures, even other places in the United States, even other age groups might not understand all of the idioms that you use. Okay, so before you say yeet too many times in your text, think about maybe the recipient doesn't understand yeet. Maybe you don't even know what it means to yeet. I certainly don't know. For all I know. I don't know. What does it mean? Someone want to put it in either chat? Yeah, there we go. An example in the YouTube chat. What does '07 mean? Not somebody in that group. What does '07, lowercase '07 mean? Is that a crappy James Bond reference? Huh? What is that? Here, I'll do one that we used to do. How about this? As universal as it can be, so universal, it gets turned into an emoji. I got some responses. '07 is for the troops. Someone else said James Bond. Someone said it's a salute. Someone else said they once sent yeet to their team at an internship, and it was very happy that it was their last day. Well, it would be your last day if you sent yeet to the wrong people. Some people might not understand what that means. Another problem with idiom, and I hate to say this, is that what is a nice, clean, beautiful meme or expression today will quickly become a slur in a couple of years. And in today's internet culture, someone may very well reach back into your previous commentary and not realize that what was once an innocent expression has become not so innocent anymore. That happens all the time. I won't even list the examples because I'm sure everybody knows the once innocent expression that became not. And so the point I really want you to take home is that you should try to communicate in plain English always, just like the reading material that you looked at said. Many people, successful, high-level professionals, try to do all of their writing in plain English. That includes CEOs and insurance company management, and all sorts of organizations know that you should be writing everything in plain English when possible, because formal English becomes difficult to understand for people in other cultures, sometimes even people within your own culture. Plain English, much less open to interpretation. Say what you mean what you say. Don't use complex turns of phrase. I think we can all agree that the political sphere has become obsessed with language right now, and we can see that the war between plain and formal has become as extreme as everything else. But I'm not saying you need to speak like a second grader or not. I'm saying you gotta speak like you're normally communicating with somebody and not like you're writing a complex letter. That includes emails, that includes formal communications with your bosses. Avoid the kinds of incredibly formal language that make it harder to understand you. Try to be plain. And then maybe people 200 years from now will still know what you said, right? And yeah, avoid idioms and memes and emojis and other expressions that can easily change out from under you before you know it. With that, we're going to get into code documentation now, and we'll loop back to foreign language. Somebody said, I want to know what word he was talking about. Which word are you referring to? You talking about yeet? I don't know which word, what word that I was talking about, or someone else is talking about. We're going to go back to formal language later. You might have some in-class assignments while we're reviewing other things. Oh, someone wants to know, what was the once innocent word? Okay, I'll give a couple examples of things that were once innocent but no longer. So if you ever took a photograph doing this, right, okay, that might no longer be particularly acceptable in a certain environment. If you ever made a meme of Pepe the Frog, that might not be acceptable any longer. I think I had some rare Pepes as early as 2010 or something, but not very culturally acceptable anymore to post your Pepes. All kinds of different things like that. And then all sorts of cultural terminology to, anything you heard in a rap song in 2008, you probably can't say anymore. Right? Some things you can. Someone said they really killed Pepe, feels bad man, and someone else said they lost all monetary value. Yes, they did. When Pepe became a racist meme, he lost all of his monetary value. So sell your Pepes now before they're completely worthless. Even your gold Pepes. Get rid of them all. How do you formalize Pepe? What's the formal language form of Pepe memes? It's the formal language form of feels bad man. Something to think about. Maybe we'll do that. Rewrite memes in formal language. Or rap. Either of those. But on to code documentation. Alright, this is something that should be relevant to all of you. I wanted to put this early on in the lecture series because I've seen a lot of you writing code in the senior design class already, and I see a lot of what you're writing is clean and pure and free from the terror of any kind of documentation whatsoever. And that makes me sad. And I still see a lot of people write their assignments and stuff. They'll come to me during office hours and they'll have no comments, right? And then they'll just quickly add a bunch of comments for the submission. And that's cool, whatever, you do you. But me, when I write code, I actually write the comments first. Sometimes I don't write the comments first. Sometimes I write them after I do like my input and output setup. But I write the comments first. Make the code match the comments sometimes. Make the code match the documentation. And this is a pretty decent way of doing it, actually. A lot of Agile models recommend something like this. There's something like documentation-driven development. There are things like testing-driven development too, test-driven development, where you write your tests before you write your code. There's a lot of different schemes like this, a lot of popular schemes like this, where you write something else before you write the code. And those are all good. They all have their own advantages and disadvantages. But what I really want you to do is not write all your comments in batch after you're done programming, right? So at least write the comments when you're done configuring a particular unit, all right? You shouldn't write them all at the end because you'll definitely forget stuff as you go. Okay, it's pretty much a guarantee. And as you try to write other portions of it and you have to go back and make changes, make sure that you're updating your documentation. One of the worst things you can do is leave an inaccurate comment. So you always need to make sure that your comments are accurate. This is why the book Clean Code, which I think is one of the ones recommended to you here, tells you actually not to write documents because the odds of a comment becoming incorrect or not reflecting what the code actually does is very high. Okay, so you don't want to have an incorrect comment when the code is actually right. That would be really crappy. Like if you have a comment that says sets this to 4 and it actually sets it to 2, that becomes a bug that's 10 times harder to diagnose. So you always need to make sure that you're updating your documentation. That also means that you shouldn't be documenting very specific implementation details that are likely to change. And that means that once you've committed to a certain typing scheme or something like that, it's probably something that you need to stick with unless you're willing to make that investment and go back and change all of your documentation. But anyway, get into the habit of documenting your units as you make them now. You should get into that habit because it will be forced into you probably in the workplace anyway. Everyone's going to reject your undocumented crap. And if you're at a company that doesn't reject your undocumented crap, then they're probably not helping you grow as a programmer, and they're probably a crappy company to begin with. So maybe just bail out of there too. All right. Who is documentation for? Why are you even bothering to write the documentation? So roughly in the order of importance of which party it's for. First, people who are integrating your code into the larger body of code. And that includes yourself, because every time you write code, you also integrate, and we'll go into that later. Then you're writing it for your colleagues. They're the ones who are probably going to need your comments the most on a day-to-day basis. And then there's also the dumbest person alive, the dumbest person on the planet, you a month ago, right? So you're writing it for your future self, because the biggest idiot in the world is always yourself in the past. So you want to write code to make yourself look like less of a dumbass, right? So if you're looking at it in a month and you're thinking, who wrote this crap? Well, you should have documented it better. Okay, to an extent, you write documentation for your bosses. I was debating putting this one further down. I mean, the actual code documentation, most bosses aren't technically savvy enough to bother, but maybe your manager who happens to be a programmer would probably read just the documentation rather than reading the whole body of code written by all subordinates, just to get a feel for where the program is going. That would probably be where they'd look. But it might not be an issue at all. Your boss might never read your code or your documentation, so that could also be a possibility. But in the same category, most organizations practice something akin to code review, where a professional, usually someone senior to you or one of your peers, will review your code, tell you where it sucks. This is where documentation is very helpful. I would lump this in the same category as your bosses, even if they don't necessarily have authority over you. Your documentation helps the code reviewer understand your state of mind and what the thing is supposed to do and how it's supposed to function and all of that. So you will get more positive code reviews, which translates to raises and promotions and all of that stuff if your documentation is good. I would say it's more important to have perfect documentation than perfect code in terms of your career advancement, because perfect code that's extremely complicated, right? Code reviewers are not always the smartest people on earth. This is not their priority. Imagine if you were doing it, it probably wouldn't be yours, right? Especially if you have a job aside from that. They might not appreciate your brilliant 6 lambda statement, hyper-efficient super block of code that has no documentation on it. In fact, the fact that they had to figure it out might frustrate them so much that they're willing to give you crap in the code review for it. It's more important that your code is well documented and integrates well with the team and is readable by others than that it is perfect. Sorry. That's just the way it is. And that is the way it should be. It's not a dig on the technicals of it. It's even if your code is beautiful, if it doesn't integrate well into the rest of the project, it's very difficult for anybody to call it good. So then the team that's getting your project in the future, and this might not be a team that ever looks at your source. So I think most projects probably, once they are finished, are packaged up and never looked at again. But they might become a library or a dependency for something else in the future, or at least some part might. Or modules of your code might be salvaged and reused in another project. Definitely a common thing, reuse, recycle, especially in programming. And so the team getting your project in the future, they definitely don't want to look at your source, especially if they're coming down the road maybe in 5, 10, 20 years. Your programming language is defunct, your version's defunct, your IDE is defunct. All that stuff by some miracle happens to still compile, and they insist on still using it. Of course they're not going to want to make any changes. At that point, changes they're very painful to make in general. So they want to know all the quirks and the bugs, and they're just going to live with it as is. You never know how far in the future your stuff is going to get pulled and recycled again. Pretty near the bottom is your present self, right? Documentation, not super important to your present self. It helps to keep you organized, helps you understand where everything's at. Probably not necessarily that useful for most of you as you're writing your code. Definitely if you've got something where you've got like different types, and type 1 is this, and type 2 is this, and type 3 is this, you don't want to memorize that stuff. You want to write a comment that you can reference right there in the present. I mean, that's not even something you've probably memorized in the present. So make sure that you give yourself those helping tools. Somebody posted COBOL in the chat. Yeah, there's so much COBOL code out there from the 60s, 70s, 80s. I'm not sure about 60s, but definitely 70s and 80s that's floating around, still being used today in 2020. Most of the people who wrote it, not just retired, but dead, right? Because it's been so long ago. You can't ask them anything. You don't want to make any changes to it because good luck making changes to COBOL today. Good luck getting a COBOL IDE and setting it all up and stuff. But those beautiful modules in COBOL, they still compile, they run on modern machines. So, man, if you just want to use one, you better hope it's well documented, right? That's one thing they did generally pretty decently back then. Someone else said that COBOL is a disease and Google scripting is the cure. X is the cure is probably never true. There will never be a cure for legacy programming languages because legacy programming languages are too good. As anybody who's ever worked retail knows, that little IBM terminal prompt that they invented back in the 70s or so, that thing will probably stay forever because in all the time that you've probably worked on it, it's probably never crashed, errored, or slowed down. You can't beat perfect, you know. Mouse support doesn't beat perfect uptime. Probably never will. And then last year, documenting for outside observers, people who might be learning from your code or studying it in the future but aren't necessarily using it. Those are less of a priority, but you always want to be a little bit conscious that somebody might be using your code as their learning experience, especially when they're the team that got your project in the future, but their goal is to replace it, right? You want to make your modules easily replaceable. They should be rewritable from the documentation. So today we're just going to talk about integration, that very first category of use. What does it mean to integrate code? Okay, this is not busing to different schools, by the way, or whatever you've probably learned commonly integration means. It's also not mathematically taking the opposite of the derivative on stuff. Integration as in combining different parts of your code together into one. You've probably heard of integration testing and all that stuff. Someone posted in chat, that's how my company still counts and records their money. Well, pretty much every retail company across the world still uses the same IBM retail inventory and finance and everything software. Basically, stock as it was written back in the 70s or 80s. Very few changes or improvements have been made. You've probably seen it if you haven't worked with it. It's a black terminal with green or white text, no mouse support. Everything runs on the keyboard, and everybody from your fresh 14-year-old that's never had a job to 75-year-old grandma who is working at the cashier's desk to supplement Social Security can figure it out within 2 weeks. Everybody gets it. Incredibly easy to use. It's incredibly fast. It never goes down. It's just generally so good that it's stuck for, as long as it's been. Oh, look, that's Nate. So Nate's not paying attention to lecture. He's playing RimWorld. Look at that. I caught you, Nate, and so did the rest of the class. You guys didn't see that Steam pop up, actually, because my head's in the way. But now you know. Nate's playing RimWorld. All right, so integration is when you combine small parts of the code. So typically we call individual modules of code. And when we're talking about agile models or agile programming, we typically call them units. They've gone through numerous names over the years, and different organizations will still call them different things. But we're just going to call them units. You could say like functional models or something like that. We're just going to call them units. So when you're an individual, you work for a large organization. You write small parts of the program. You don't write the whole thing. Generally, people don't write the whole thing on their own. They're developed by teams. So you write just a very small part, and then integration is the combination of all those small parts that everybody's written to make a program. Generally, you don't do this all at the same time, right? You don't all write a small piece and then come together on one day and combine everything. Things are merged together a couple at a time. Integration includes also when a unit is merged into an existing program, so when functionality is added, a unit is changed or updated, it needs to be reintegrated, or a unit is removed or replaced. Sometimes you would call that refactoring, but that's also reintegrating as well. So anytime that an individual piece is changed and then it needs to be integrated or merged back into the whole, you have a very complicated problem, right? Because you've made a change to a small part. What can happen to the rest of it? Integration is really hard. It's very hard. It's probably the hardest part of the whole programming experience. First of all, each of those little individual models is made by humans. Humans are not very detail-oriented. They don't always follow the specs perfectly. They don't always do a perfect job. Your homework is definitely evidence of that. I can't tell you how many times an assignment has had a very simple requirement, like put a space between the two things that you print, and somebody doesn't put a space. Little details like that build up when lots of them are out of spec. I mean, I definitely have to force people to turn in zips and things like that. You know, I have to set all these canvas restrictions, because if I tell people turn in the content of your source folder, follow these instructions exactly, I always get something slightly different if I just leave the submission open to everybody. Right, so there are always problems with people following specs. Specs are long and complex. People don't always follow them. And mistakes in specifications and just bugs in the code will propagate to other units. You will quickly find that any even minor problem in the spec of one unit will propagate to others. And sometimes an individual unit is perfectly up to spec. It has absolutely no problems, and it runs great. And even so, a change in functionality may break another unit. In fact, sometimes another unit depended on what was actually a bug in a previous unit, or depended on a different unit being out of spec. So it took an input that was out of spec and fixed it. You bring the input back into spec, and now it's broken. There are all kinds of things that go wrong when you do integration between different units. And because this is the hardest part of the experience, this is the main reason that we document, to make integration a little bit easier. Every time you have integration, regression often follows. Why do we use the word regression when we talk about code? We have regression testing, we have code regression. Those are common expressions. A regression is when something gets worse, right? Goes back, regresses, becomes inferior to how it is in the present. After integration, code tends to regress. It sometimes gets worse. We hope it gets better, but other parts of it sometimes get worse. At the very least, right, when you add a function, your performance regresses. When you add some sort of efficiency upgrade, maybe your readability regresses. Maybe some aspects move forward, others regress. So after integration, we usually have something called regression testing. We'll rerun a bunch of tests to see if the code changed or if the functionality changed. Now, this is an area where documentation usually doesn't really help us when we have regression issues. Usually that's because of a bug in the code that usually does require us to read the code. So it's an area where documentation's not as useful, but it can still sometimes help to diagnose these issues. All right, so what does it mean to make integration easier for your team or for yourself or whatever? So you need documentation that makes it very easy to understand how all the different units in your program work. And what is a unit? We'll talk about that in a bit. But it needs to be understood without reading the code. That's important. Now you might say, okay, everybody doing the integration, everybody here is a qualified programmer. Sure. Okay, but when your project gets big, when it's thousands and thousands of lines of code, it can become very, very difficult to interpret. Reading code already is hard. Reading complex code, which is any code that performs a meaningful task, as you've learned in senior design by now, anything that does something worth doing, it's a lot harder than your homework is in terms of readability. It ends up with a real nightmare of readability. So anything worth doing becomes complex very fast. And complex code that other people wrote is especially hard to read, no matter what, right? Even if it was just yourself a month ago, that's about the same as it being somebody else. And by the way, senior design project spans 16 weeks. We're only on week 3 or 4 here, depending on how you're counting. So you will be you a month ago very soon, and then you'll be you 2 months ago after that, okay? We're talking about basically a 4-month stretch, 3 and change, because there's not exactly 4 weeks in a month. We're talking about a 4-month stretch, basically. So you will be future you very soon, and you will hate past you very soon, all right? So don't think that just because this is a short-term project, you don't have to deal with your past self. You will deal with your past self over the course of 16 weeks. That's not a particularly short time frame, right? So complex code other people wrote is very hard to read. You don't want to have to look into the code to diagnose problems with it. If you're doing that, it's a massive time investment. And even if code's been removed, or if it's going to be removed, if it'll become defunct, if it is defunct, depreciated, whatever you want to call it, it's very important that you understand what all of the defunct code did too, because bugs might not emerge the day you remove a piece of code, right? They might not emerge the day you depreciate someone. You might not notice that you were depending on some functionality there until a week from now or a few days from now. And then you have to go back and read the defunct module and see what did it do that the new one doesn't. So all of your modules need to be meticulously documented in such a way that you can understand what they do without having to read their code. So let's talk about what's important to integration. I've got this in like 4 or 5 parts here. So the first part is inputs. Input includes everything that you need to know in order to implement a particular unit, okay? And a unit might be a class or a method or an object. It might be functions. And remember, there are different kinds of programming. We teach object-oriented programming here. Some people still swear by functional programming. What you consider to be a unit of code is very arbitrary. It could be a whole object, it could be a method, but the smallest possible unit that you include should still be well documented. Okay, usually the smallest possible unit is the method or the function. So everything down to at least the method or the function should be well documented. So document all the inputs that are required and how they need to be formatted. Most programming languages will auto-generate for you whether or not a method needs a double or an int or a float or a double. So you don't need to say that stuff, assuming that the development environment you're all using already indicates that, and that's not important. But what kind of double? Like, what are the ranges? Does it have to be a positive number? Can I have 0? All those different kinds of things. If it's a string, can it just be a string? If it's a file, what's the file in? Is it UTF-8? Is it 16? Is it 32? Any kind of thing that the people that are using your module who are not you would need to know. All right, any kind of setup process that yours requires as well. This is where Swing really fails, right? So in order to get a frame working, you have to make the new frame. Then you have to pack the frame. Then you have to set it visible. Where does it say to do that? Where in Pack's documentation does it tell me that in order to get this to work, I need to set visible? I need to refer back to basically their master documentation on Oracle's website and then read a sample to figure out that that's how you're supposed to make a frame. There should be something about the whole setup process, probably in Frame's constructor, to let you know how to do that even. I don't know what the best way to do it. The best way to do it is to avoid complex setup processes in the first place. But if there's a complex setup process, if it's like you need to run this method first and link them together, then do this, then do that, man, that should be somewhere important, probably in the constructor, definitely at the top of your main documentation, because any kind of quirky, weird setup process requires documentation. If your code fails on weird inputs, like it takes positive integers except 3, let the user know. Anything that's strange and incompatible, let them know. If your program accepts text files, but not text files that are named text file, that should be in there somewhere too. Best way, though, avoid quirks and incompatibilities in the first place. But man, that's easy to say, sometimes hard to do. So if you've got those and they're not that big a deal, just put them somewhere in the documentation as well. This means that every class, every object, and every method should have a robust Java doc or equivalent header that tells you what you need to do to make it work. The easiest kind of documentation is the one that's directly in the IDE that doesn't require you to go to the internet to access. Okay, to the broad internet, obviously the docs get pulled from somewhere too, but the easiest kind of documentation is the one that happens when you hover over the object or the method name. There are certain libraries in Java that I can use like without consulting the internet at all. Like I can just hit the ground running with them. Like anything in the math library, super simple. Let's see, anything in the random library, super simple. Swing, not bad. Very rarely do I have to consult on anything big. But if I get to like the crypto libraries in Java, like good luck. The setup process is tremendously complicated. You're always looking in line because none of the documentation is helpful on any of the Java crypto libraries and stuff like that. Like if you're working in, I work in C# a lot. Those are all beautiful for the most part. Everything Microsoft built in, really good. But again, still every once in a while, there's something out there where you have to consult the internet. So try to make that happen as little as possible. Try to make it so that people only have to search online for examples or things like that. Everything that you need to know to make it work is already in the comments. You can ignore getters and setters, but really good documentation doesn't. They still put a little bit in the getter and setter, like what kind of thing you're getting back, what kind of thing you should be providing. Even if it's obvious, I think really good documentation tends to improve those. You'll see that in your homework. I give you an example of what I think is a really good piece of documentation, which is Java 11's documentation for the color library. All right, and that one documents every getter, every setter, every variable, everything, right? And that's really good because you know what everything does. No one should have to read the code to understand your inputs, definitely. All of your inputs and all the quirks and all the formatting requirements should be baked into the documentation. Somebody should be able to use your module without having to look into it and see what its limitations are from an input point of view. All right. You also need to explain the functional limitations of your module if it has any, and most pieces of code have some kind of functional limitation. They're not perfect. They're built for a limited purpose. Oftentimes you don't know what the functional limitations are until much later, so this is a comment or a series of comments that you are always updating. Okay, this might be a disclaimer or something at the top. It might be at the bottom of your headers for the class or the method. This is something that you're probably discovering as you go. We'll see this a lot in different Java libraries. So we'll see, for example, that hash map will tell you this can't be threaded. Use hash table instead. That's a great document. It tells me, okay, if I have a threaded application, I don't use this one. It could save you a lot of work if you're trying to use hash map and you only realize quite a ways in that it doesn't support threading. And then, of course, table tells you this can be threaded, which is a functional plus that's not usually available. So good. All right, great. If I need to thread, I'll use hash table. If your program fails when the connection is lost, or when the file is closed, or when the user does something strange, or when they click the X, or if they click to the left side of the screen too long, something like that. If your unit needs to be refreshed, so if something needs to wake it up every 30 seconds, or if you need a steady connection for it to work at all, list all of those different kinds of functional limitations in your comment as well. How and when is it known to fail? What does it need to keep operating? Some of you are working on like sheet scripts, for example, with triggers and all those lovely things. When do your triggers fail? What do they need in order to keep working? How do you upkeep a trigger? Like, what do you do if you want to remove it, change it, whatever? Some of you are working on like database communications and stuff like that. What happens if the database is inaccessible? What happens to the modules that depend on it at that point? What happens if the database is slow to respond? In the database, what happens if you send it some bad input? These are kind of functional limitations too. What happens if the machine is overburdened and network connections are lost? There are all kinds of different things that you can describe as limitations here. This is different from known bugs, right? So known bugs should be separate from the rest of the documentation. They should be easily searchable, so I recommend that you categorize them somehow, numerically, alphabetically, whatever. They should be searchable, like this is bug 547A or something. So they should all have unique names and categorizations, and that way that's often very helpful. Bugs are different from failures because bugs are not by design. Failures might be by design or by necessity. These are features. A bug can become a feature if you don't have a method of fixing it and you just decide to live with whatever failure mode it happens to be. But the user unplugging their mouse and the program crashing, that might not necessarily be a bug that might be a failure mode that you want to have for some reason or another, or at least a failure mode you're willing to live with because fixing it is not worth the energy. Just like with inputs, you should outline how all of your outputs work, the format. You'll notice this is basically a copy of the input slide, right? So all the outputs of different modules of your program should be meticulously documented for how they are formatted, what quirks and incompatibilities there are in the output. Again, generally your IDE will tell you if it's a float or a double or a string or whatever, so that stuff's not particularly important. It's like, what kind of float, what kind of double, what's the largest number you can get, what's the smallest number you can get? Will you get negatives? Is this always going to be a positive? Will it ever be zero? What happens if you give it invalid input? You'll notice, like in the math library, what happens when you try to divide by 0 in float space? You get infinity. That's weird, right? Dividing by 0 gives you infinity. What happens when you divide by 0 with an int? You get an exception. Okay, so document that kind of thing too. I think both of those things are well documented in the Java math library. And again, this means class and method headers everywhere. Luckily in Java, every time you make a header, you get those @param and @return fields. Those let you describe your inputs and outputs. Use those places to describe your inputs and outputs in more detail if they have functional quirks. And a note on unit tests. So you should be writing unit tests, but of course when you're time limited, it's one of the first things that you tend to skip, right? Which is unfortunate, but it is what it is, you know. If something's got to go, it might as well be unit testing. I get it. Unit tests are not a substitute for real documentation, but they can be helpful. And if you're going to write unit tests, you should write them with a mind to them being useful as documentation to an extent. So often unit tests are written just like as they're thought of and in no particular grouping or no particular order, or they're just roughly grouped by like, type like boundary checks and, I don't know, user inputs, whatever. So try to group your inputs in such a way, your unit tests in such a way, that they can be useful as documentation as well to help other people understand what are acceptable input ranges, unacceptable input ranges, where your module is expected to fail. Unit testing provides a lot more information than you're probably going to be willing to do in the comments. Because like with everything else, going back to some of the things we learned in the beginning here, being brief is the most important thing. There is no use at all to a 20-line method header, right? Because no one will ever read it. No matter how meticulously you've documented everything in that method and all of the functions and uses, a 20-line method header might as well be a 0-line because practically nobody will read it. That's not exactly true because there will be some people who are dedicated enough to read the whole thing, but in general, the longer it gets, the less useful it is. So as all this information that you need to include, you still need to consider that it needs to be included as briefly as possible in order to make it useful. And same for your unit tests. They should be as clean and as concise as possible so that they may be useful to anybody who's looking at more details of what kind of inputs, outputs, etc. your program generates. Remember that all programming requires integration, even when you code alone. When you write small units, you'll write like a method, and then you have to integrate the method back into the body of the rest of your code, right? So even when you're coding by yourself, you're still performing units, then integrating. You're writing units, then integrating. You're always writing and integrating your code. And then when there's a mistake, you go back and you alter a unit. Sometimes you're doing integration testing. Sometimes you're trying to see what the addition of a unit broke or how adding a unit caused additional errors. Most of the time, you're working in units, and then you just hope that the integration works correctly, right? And part of that hope is that whenever you write your units, you plan to how it'll integrate with the rest of the program. Well, it's easy to do when you're the one that wrote the rest of it, right? It's a lot harder to do when the rest of the program is written by many, many other people, maybe dozens, maybe a few, like in your groups of 4. But whenever you're writing your unit, always think forward to integration. Not just how can I write the code to make it easier to integrate, but what knowledge is going to make my unit easier to integrate. Your units, as you write them, should be as flexible as possible, such that they're integratable with as many other pieces of code as possible. Oftentimes, that's not possible either, because the rest of the code has very particular formats or whatever to make it integratable. And that's okay, but still, try to make your modules as easy to integrate as possible, and always write documentation as you're doing it in a forward-thinking way, addressing integration in the future. All right, so your colleagues, they also write units, right? On that note. And generally speaking, you're going to standardize your documents for your organization. I recommend that you do this for senior design too. There are already pretty decent built-in standards in Java. You know, when you do the /** and you build your method headers, the Java docs have a lot of standard fields. They also, I think, accept standard just HTML, like BR and things like that. You can also do formatting there as well. Make bullet lists, things like that. But you should have a standard sort of template of the order that information goes in. Do bugs go last, second to last? Where do the kind of quirks go? You can build this naturally over time, but try to make sure that all of you are writing your unit tests in approximately the same way. Sorry, unit documentation in approximately the same way. Make sure nobody is writing like their documentation is a series of bug reports while somebody else is writing it as an essay. You should use similar language. It should be obvious by now, but never use language like this method does, this class does, this object does. You can omit that stuff. You're going for brevity. Just say what it does. And remember that your comments should always be forward-thinking to integration, what makes your module as easy to integrate as possible. Make sure that you're not trying to be special. This is not creative writing. This is informational, highly technical writing. You are trying to help people to understand your code in the future. Make it easier to integrate. You're not trying to win points for writing the most flowery documentation possible. So any questions before we look at a couple examples? Any questions? All right. So the thing that people most often integrate is going to be libraries and things like that. Although people generally don't consider APIs and libraries and things to be integration, those are things definitely that you've integrated into your code. So let's look at some of the simplest of them all. Let's look at Java 11. Let's look at, let's say, the math library. Okay. So this is the math class in Java. And let's try to find the most common, let's try to find the hardest thing, something that none of us are really familiar with. How about IEEE remainder? That's a tough one. All right, now I'll zoom in here a bit. And by zooming in, I've lost it. One of the nice things about Java is that the Java docs, once generated, it's very easy to turn them into a page like this. So all those /** method headers and stuff that you do, the reason that they accept HTML in their formatting and all of this stuff is that it's incredibly trivial. I think you can auto-generate in Eclipse a page exactly like this, and you can host it on your GitHub or your site web page or whatever. And you can very quickly have a page that looks exactly like this from your own method headers. Okay, that's another reason that I often insist that you do the method headers well. Notice how a lot of these are structured, you know, they computes, returns. Perfectly fine language. Nobody says this method returns, nobody says that. They say returns the largest. Again, let's look at IEEE remainder. The short form comment summary is computes the remainder operation on 2 arguments as prescribed in the IEEE 754 standard, where IEEE 754 standard is not clickable. Oh, how do I figure out what the IEEE 754 standard is? Oh, good, they tell me, right? And so if it's something like that, isn't it nice when they tell you the remainder value is mathematically equal to f1 minus f2, which correspond directly to the names of the parameters. You can reference parameter names in line. You should notice that f1 and f2 are a little bolded here. That's because those are references directly to those parameters that they've included. Mathematically equal to f1 minus f2 times n, where n is the mathematical integer closest to the exact mathematical value of the quotient f1 minus f1 divided by f2. And if two mathematical integers are equally close to f1 over f2, then n is the integer that is even. That could have been simpler, couldn't it have? But I think that that's about as simple as you can make relatively complex math. Then it goes into quirks. These are important quirks. If the remainder is 0, its sign is the same as the sign of the first argument. Special cases. Quirks, right? Special cases. If either argument is not a number, or the first argument is infinite, or the second argument is positive or negative 0, then the result is not a number. That's a lot to consider, right? But those are very helpful things to list indeed. If the first argument is finite and the second argument is infinite, then the result is the same as the first argument. Another very helpful thing. So, beautiful structure here, a good description, a good list of quirks. Let's look at another language. You can type other language suggestions for me in chat, and I will look up their IEEE remainder library here. Somebody asked if I put the slides on Canvas when I'm done. Yeah, I try to upload them. Just shoot me a reminder if I forget, but I think all the ones so far I have uploaded to Canvas after I'm done here. Or, of course, you know, this video stays up, but yeah, I don't want you to have to scroll through the video to see them. They're definitely up on Canvas there. It's not like I've got the highest quality slides in the world, guys. And also, I apologize for not having any images, dank memes, or anything of any interest in my slides this time. I'm mad scared of YouTube's super duper copyright strike crap, so I just haven't put anything at all in any of my slides just to avoid any kind of copyright nonsense at all. So let's look at C sharps. What did they call this? IEEE remainder. It's probably in the math library. Remainder? It'll autocorrect for me. Here we go. They got math.div remainder. Oh, here we go. IEEE remainder. Let's see how Microsoft did. Somebody commented generic rights-free music is missing. Yes, I would like to put generic rights-free music, but even generic rights-free music gets you bogus copyright strikes for no reason. So just gonna dodge that altogether. I can play you guys some banjo or something. Ba-da-ding, ding, 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 ding. What are the descriptions of C sharps directly from Microsoft documentation here? First of all, points to them for having a dark mode. Good on them. Second of all, again, just like in Java, these can be auto-generated in a very similar format. So they will have a, it's 3 slashes, I believe, to start a method header. 3 slashes and then summary. I think if you just do // in Visual Studio, it'll do summary for you automatically. And again, I believe it takes HTML like BR and all that stuff. And again, they've referenced directly to inputs here. That's why they have a special little box around them and all that lovely stuff. Now, what's their description? So, X, a dividend. Y, a divisor. Compare that to Java's the dividend, the divisor. Perfect. Both of those. That's a tie. Returns, double. Compared to Java, returns the remainder when f1 is divided by f2. I think Java gets the win there in terms of simplicity. Returns double, not helpful. Bad C sharp. A number equal to x minus y q, where q is the quotient of x divided by y rounded to the nearest integer. If x over y falls halfway between the two integers, the even integer is returned. Compared to Java's, I think Java wins this one pretty handedly, right? Their description is better, and they don't even reference the IEEE 754 standard for you to consult in the C# documentation. I think that is nowhere to be found. It's all the way down in the remarks section. Okay, not bad. I'll give them credit for having it in the remarks section. Now, where C# really takes the cake is in that they have examples, right? So they've got a fully functioning example of IEEE remainder and regular remainder so that you can compare them together. They've got outputs listed there as well. this is something that's very helpful if you have a complicated piece of code, a complicated to integrate module. It's excellent to have an example of how to use it in your documentation. And this is where I think Microsoft has really been dominating the documentation game, and why C# has quickly become my language of choice for pretty much everything, because they always give you examples of how to use it right there. Now, they're not always the most useful, and sometimes they're structured a little weirdly. This is pretty weird in that they've decided to make show remainders of static method, and then they've got this weird kind of extra stuff with the console.writeLine and whatever. But they're always easy enough to understand, so I give Microsoft and all the C# library documenters a lot of credit for doing this, and I hope that you guys will do the same when you document your stuff, have an example of how to use it. All right, and what else should I say? There's nothing interesting here in the example section. Again, going back to Java's, you don't have a lot of examples in the Java documentation in general. Sometimes you'll get simple examples within the body of stuff. Let's see here. Yeah, you get a couple line examples in the Java docs, which is not bad. So broadly, Java docs are okay too, but C# definitely takes the cake in that, even if Java's explanations are easier. Now, generally, the example's not going to pop up when you hover over it. That does require you to go to the internet, right? So it is a little bit less good than it just working without you having to go online. You being able to do it from the hover is much better. And a remarks section like this is very useful too, being able to compare them. Obviously, this one goes into a lot more details than Java's. That's great. It tells you all of the different versions that it applies to. Java groups theirs by which version it applies to instead, so every version of Java gets its own documentation. I think Java wins in that department, because having to search through whether or not your framework is one of the ones supported here is a bit annoying. But you can use their drop-downs on the C# website to do exactly the same thing that Java can do, where you just pick your version and it'll automatically filter out which ones are supported. These are just better for landing on from Google. So sometimes it's hard to land on the correct version of the Oracle docs just from Google. And their search function, like every search function on the internet, is balls. So it's definitely better the way C# does it, where you can then pick your thing from the drop-down. All right, so that's just two languages compared there. There are obviously many others. Let's look at, just before we sign off and I meet with some of you for your resumes, the worst programming language in terms of documentation, which is anything written by Apple. So we're going to go with Swift, IEEE remainder. Apple decided after a certain point, sometime after Objective-C, that they just weren't going to do that anymore, writing documentation. So let's see if I can even find Swift's documentation. Well, I found the Microsoft one. Let's see. All right. Let's just look for Swift documentation and search it internally. There's no search here, is there? There's no search here. IEEE remainder. Looks like there aren't any great matches. Okay, Swift loses for not having one. This is a basic API function that's probably pretty common to use. We'll just go with remainder then and see what we got. Developer.apple. They called it remainder and then dividing by other. The value to use when dividing this value. That's about as useless as you can say. It's called the dividend and the divisor, guys. The remainder of this value divided by other. Well, yeah, the name of the function is remainder. That's not very helpful, but okay, I'll give them that. It's not bad. For two finite values, x and y, the remainder of r dividing x by y satisfies x equals y times q plus r. That is borderline unparsable by mere human, right? It's definitely the most complicated way of discussing what a remainder is. And their example, kudos to them for having one, but they almost may have not bothered. with how strange it is that it has some kind of weird x over 0.75 rounded to nearest even that is totally superfluous to the functionality here. So I'm not sure why they included it. And then that's it. I mean, that's the whole documentation for that. So boo on Apple for not documenting Swift at all. All right, so those are a couple examples. Your homework is going to be something similar. I'm going to post it right now so you can work on it while I review the last few resumes with the few people who I still haven't gotten around to. So if there are no more questions, I am going to sign out, post your homework, and meet up with those last few folks. So thanks for tuning in, guys. See you very soon in senior design. And there will be a lecture today in senior design, by the way. Quick one, but there will be something. All right. See ya.